What if I told you you can build a legit rocket in this bedroom? Well, you can, because I did it, and I'm here to teach you how to do it. See, building this rocket is complicated because its objective is to reach space. But what if we reduce its size to something like this? Now, it becomes much easier. So let me show you how to do it. But before, let's learn some basics. You see, a rocket needs to go from the ground to a certain altitude. It has to go through air and counter a force that we call gravity. But how do we do that? You see, a wise man once said, to every action, there's a reaction. Although it's very true for life, it takes all its sense in physics. Did you ever do skateboarding? Well, imagine you're on a skateboard at rest. Also imagine that you have a soccer ball on your hand. Now, throw the ball on the back, and strangely, you will go forward. You created the force by throwing the ball. But what does the third law of Newton say? To every action, there's an equal opposite reaction. So let's come back on how do we create the action force. We threw the ball, and by throwing the ball, we ejected something from a rocket in order to go forward. Okay, let's translate that to a rocket. In order to make a rocket go forward, we need to eject something on the back. We have to create thrust. And that's the purpose of the rocket motor. You see, there are different categories of rocket motors, but we, rocketeers, are interested in one called SRBs, which is essentially you burn solid fuel that then turn into hot gases that then leaves the rocket at high speed. There are a large variety of SRBs on the market. They're named after some letters going from A to O. A being a rocket motor that can bring your rocket to 20 meters of altitude, whereas a O motor could literally put your rocket into space. Okay, they are also named after their average thrust they can deliver. For example, this rocket motor has an average thrust of 250 and is of category J. It will be then named J250. But if you have just one rocket motor, you will get something like this. Okay, I admit it's very funny, but eventually we want our rocket to go up higher, faster, have some flight data, and we want it back on the solid ground safely. But to do that, we must learn about components. So guys, welcome to Rocket Science 101. Don't worry, you will not be bored. Okay, to start with, we have the most basic component of all, and that's the body tube. You see, the body tubes needs to take all the shocks during flight. For example, for this rocket, I use those tubes, and I have to tell you they're very, very, very strong. I had a problem with a parachute, and the rocket went down at 70 kilometers per hour, and those tubes and that rocket also hadn't any damage. So it is essential to have body tubes that are strong, that are light, and cheap. okay? There's one misunderstood concept about body tubes. Well, I think you all believe that to make a rocket, you need large amounts of steel and tools. But the reality of facts, you can just take cardboard. Well, they are stronger than we think. For example, for my second rocket that I made, that you can see on my stand, I used body tubes, cardboard body tubes that are found in the streets. Could you imagine that we become a fully functional rocket? Well, I did at first, but sometimes fancy things are not the optimal solution. Mark my words, an engineer is not a person that can design an object, but a person that can design an object with what he has. Okay, so let's move on the upper part of the rocket, where we have the fundamental parts, the nose cone. I believe you all know that water is considered as a fluid. But what if I told you that air that we breathe is too? Well, air and water could be considered as a similar thing. Okay. Did you ever try to put your hand into water and push the water? Well, did you feel that resistance while you were pushing on the water? Well, let's take another example. Did you ever try to put your hand outside of the window of the car? Okay. Did you feel the resistance also? Well, that resistance is what we call drag. And did you notice also that when your hand is wide open, you feel more that resistance, and when the car slows down, suddenly that resistance is gone. Well, what this childhood experiments tell us? That drag, the resistance of the air, is more present when you go faster and when the surface in which the air flows is greater. And tell me, what goes very fast? You can guess it. Tell me.
Rockets.
A rocket, you guess it. And it goes so fast that it creates a lot of drag. And drag, means lower velocity, lower speed. And lower speed also means lower altitude. And as rocketeers, we want a rocket to go high up in the sky. For that, we need to create a component that helps the air flow on the rocket. And that's the purpose of the nose cone. You see, the nose cone comes in different shapes. You have shorter ones, like the one I used on my first two rockets, Icarus and Daedalus. I made them that short because my 3D printer had a limit. So they're not so strong. But you have also nose cone, like the one I use on Hercules, and those are very, very strong. They're longer, and they have a metal tip on the top. And we use that metal tip because that point of the flight gets very, very hot. Okay, now that the rocket goes very high and we go fast, we have to think a way to get back the rockets, because it's a shame to be searched by the CIA for launch of ballistic missile, right? No, just kidding. But just in case, we need to think about a parachute. The purpose of the parachute is to slow down the rocket enough to don't have it have any structural damage. Okay, do you remember what drag? Well, I said that the more the surface in which the air flows, the more the drag. Okay. There's 3 steps in a rocket flight. You have ascent, where you want no drag at all, and you want to go very, very fast, to go very, very high. Then you have apogee, which is actually the highest point of your flight. And is also where you want to eject your parachute. Because there's no velocity and no acceleration. So you want to eject the parachute with something that we call an ejection charge, which is essentially an explosive charge made by the motor or your electronics. And then you have descent, and that's where you want the most drag, because you need to slow down the rocket. You can guess it. You want your parachute to be big and large, okay? And you want to slow down the rocket at 5 meters per second, sorry. Okay, and you will tell me, but how does the rocket is connected? Because if you separate the rocket in two, just like here, I will show you. You separate your rocket like this. How it's attached? Well, it's attached by something called a shock cord, which is essentially an elastic cord that is attached to the two sides of the rocket and also maintains the parachute. So the rockets stay intact. I mean, free pulse, and it stays like this. Okay. But we know now how to make a parachute and the purpose of the parachute, but how do we pack it on the rocket? Let's see a little tutorial. Well, you have to fold it in half. Fold it again. And you have to take the lines and put it in the parachute. Then fold it again. You can guess it, you have to fold the parachute again. And that's the best part. You have to roll it like a burrito. Okay. Okay. Now that we have a safe way to get back the rocket, we still need to think about 2 or 3 things. We have a problem, guys. Is that by having a nose cone that cuts literally through air, we create instability on our rocket. And that's no good. And strangely enough, in order to make the rocket stable, you have to create drag at the bottom of the rocket. Okay? Let's just imagine for a second that our rocket is an arrow. Okay? What does an arrow need? Well, our shaped head to cut through air, just like our nose cone. We need a remote tube, and can someone guess?
The fins.
Fins, right? We need fins on our arrow, because fins makes the arrow go straight up. And we want our rocket to go straight up, right? Well, we need to put fins on our rocket. You can either put 3 or 4 fins on your rocket, and you want them to be shaped well enough to make the rocket stable. But how do we know stability? Stability, to introduce you to stability, I need to introduce you to a unit of measure. And for that, we need to learn about the center of mass. I cannot tell you how to calculate the center of mass because it's extremely long and painful, but I have a simpler method. You have to find the equilibrium point on your rocket, just like this, you know? And there you have it, your center of mass. But we also need to think about the center of pressure. Okay, I'm going to make it brief. There's another force related to drag that we call lift, and is created by the air flowing into the fins, okay? And the thing is that drag and lift are related in one point of the flight of the rocket, and that's the center of pressure. Just like this. Now that we know that, we need to know where's the center of pressure. And for that, we need to use Open Rocket. What's Open Rocket, you will tell me? Well, it's the holy grail of rocketry. It's a free simulator on your laptop that can calculate for you stability, max acceleration, max speed, and average expected. It will make your life so much easier. Yeah. Now that we know that we can calculate stability. Stability, this is the only formula of this presentation. Stability is the result between the length between the center of mass and the center of pressure divided by the rocket diameter. And we have a number that must be between 3 and 4 in order to make the rocket stable. And to change that number, we need to change the length between the center of pressure and the center of mass. And for that, we need to reshape our fins. The more your fins are large, the more stability you will have. And the other way, the more your fins are long, the less stability you will have. So with that, you find the ideal stability. Okay? Well, let's just recap for a moment. We have a nose cone that cuts literally through air. We have a body tube that takes all the shock during flight. We have our fins to make the rocket stable, and we have our parachute to make the rocket slow down enough. But we still need to think about one more thing. And it's a brain for our rocket. Well, I'm not an neuroscientist, but I will try to explain to you how the brain works. Essentially, your brain needs information in order to take action. We have a nose to smell, some ear to hear, a tongue to taste. But the brain also needs a power supply. Okay? And that's the purpose of our lungs, because we breathe air, and that air is essential for our body. But we also have our heart that pumps all that oxygen in all the body. And this is all connected by the nervous system. Then, the rocket takes information, processes it, and take action. Okay? Well, what if I told you that our brain functions exactly in the same way as a rocket? See? For a rocket, we need a microcontroller, a brain, that processes information. And that's the role of the microcontroller. We also need a sensor that takes information like altitude, acceleration, all those kind of stuff. But our rocket needs a power supply. And for that, we have a battery that takes all the electricity and stores all the electricity. But we also need a switch that can allow the electricity to go around the system. Okay? We can also add a memory card to take all the flight information and save it. And there you go. You have a flight computer. And in that case, it's a flight computer for a rocket. What I like to add on my rocket is hides by adding a camera that records all the flight. Because there's no astronaut that goes up there to see the amazing view from there. So it's a shame. And your computer needs to be programmed with a language that it can understand. And for that, we use Arduino. Arduino is a coding language that can allow you to do a lot of stuff. From robotics to rockets, everything you can use Arduino. Okay. And you will tell me, where did I get all these extravagant components that you see on this rocket? Well, the motor, the things. There's an Amazon also for rocketry, okay? And you can find it all: parachute, nose cone, motors, everything. Okay? So there's some good one. Sierra Fox is perfect for parachutes, okay? European space technology is great for motors and body tubes. And Apogee Components is also great for all the electronics, okay? So, we can now launch our rocket. 5, 4, 3, 2, 1. Wait, guys. We forgot about something. And you know what is? The law. You cannot launch a rocket without permission. But guys, don't go. I have a solution also for that. You see, there's an organization called Tripoli Association that supervises the launches of the rockets all around the world, okay? And what's more, they have all the launch equipment needed to launch a rocket even into space. It's crazy. And I have great news, guys. There are 2 Tripoli prefectures around Monaco where you can launch your rocket all a year long. The first one is Rocketry France. Here's the QR code if you're interested. There's the website, and that's in Valençol, and Valençol is near Aix-en-Provence, so it's not so far away. And the second one is in Italy with the organization called ACME, and it's 7-hour drive, but it's really nice. Okay. What's more, Tripoli recognize 3 levels of high-power rocketry. There's 1, 2, and 3. And to send it, and to upgrade level, you need to send a rocket bigger each time with a bigger motor. And these certifications allow you to send rockets higher and higher because you are allowed to build rocket motors and to buy rocket motors. So here's the QR code of the Tripoli Association. If you're interested, you can see it. And while you're scanning the QR code, maybe, I want to flex it out my Tripoli card, okay? Because with that, I can buy rocket motors till the L category, and that seems quite geek, but that allows me to launch rockets to 10 kilometers of altitude, actually. So yeah, you will tell me, no, this is my palmarès, just to flex it out also, because why not? This is my first rocket called Carlos, and it's a water rocket that went at 10 meters, so not so great. Then we have Icarus in 2022 that went to 500 meters of altitude. Then you have Daedalus that went to 800 meters, and then we have Hercules that went to 1.5 kilometers and can go much higher, 5 kilometers, 10 kilometers. That rocket is built like a tank, okay? Okay, and there's a quality very important to rocketry, and it's patience. It's not a case that the Italians say that the patience is the virtue of the strong. Your 3D printer will crash, you will need to align your rockets perfectly on the pad, or you will just have to wait the launch. All those problems will occur, and you will have to deal them with plain old patience. There's another quality complementary to patience. Can you guess it? Well, it's perseverance. Because perseverance is the ability to never give up. As Samuel Beckett once said, ever tried, ever failed, no matter. Try again, fail better. And you will tell me, why all this science? Well, firstly, because I hope that someday you will get the opportunity to feel the adrenalines in your veins while you're waiting for the countdown of your lunch. An experience you will only get if you put months of hard work into creating your own creation, with the uncertainty always present until your rocket has safely come back from the sky after attaining a full speed of 500 meters per second. Then, a rocket this size are very useful for a large variety of scientific experiments, to meteorological retrieval, to literally make the sky rain, to experiment in high acceleration environment. The possibilities are endless, okay? And I have a purpose for my rockets. You see, we cannot drive your dream car as your first one, right? Well, mine is a red Ferrari called Mars. You see, I want to send humanity to Mars. So you can see, there's a long trip to go, but I always say, one step at a time, one rocket at a time. By the way, my name is Alan Offer. I'm 16 years old, and I build rockets. Thank you so much for your attention.
Thank you so much. Is anyone has any questions to Alan?
I go to FIB school in 12th grade, and yeah. Any other
question there from the...
Yeah?
Why do you like rockets?
What?
Why do you like rockets?
Why do I launch rockets? Because it's my passion, firstly, but I want to make it a job. Because, you know, my dream, I don't know why I have this dream, but I want to send, like I said, I want to send humanity to Mars. So we have to start somewhere with those rockets. And the way to get to Mars is to developing technology to get there, you know. So that technology is very hard to attain. And you need experience and knowledge in order to go there, to create those technology. And this is actually what makes knowledge and experience. By touching things, by touching rockets, by creating rockets, you create that knowledge. You will need university, right, to learn about rocketry and those kind of stuff. But if you don't touch the rockets, if you don't launch the rockets, you cannot do if your job is to launch rockets, I mean, you must learn how to do it physically. Other question? My next steps? Well, my next steps are making rockets go higher, but with the help of a group and with funds. I will try to search funds, and I really want to have a group of people, of individuals, to continue this project. And the second objective is to educate people, because there's a lot of passion about astronomy and rocketry. And so I really want to, in a way, educate them, if I can help in some way, because when I started, I looked at YouTube. So it's like this dream of building rockets, it's like 5 years. I'm trying to build rockets, 5 years that I'm acquiring knowledge, experience. So if I can condensate that experience and knowledge in one place, you know, on social medias, things like that, I think I could make it easier to people to know things, you know, and that's also my goal. Mine? Yeah. Well, I will graduate hopefully find B. And after I want to go to university to learn aerospace engineering, and maybe in Torino Politecnico, or EPFL, and Swiss. And then after graduating of that school, of that university, I will try to make it my best to send rockets. Thanks.
Have you ever wanted to go to space yourself?
Well, who didn't? I mean, but I really want to go to space. I don't know if my mother will allow it, but
Alan, just to clarify it, your mother allows you to experiment with explosives in the house and make rockets. So.
yeah, right. But there's my father also that's helped me, like, negotiate with my mom. You know? So okay.
I have a question as well. Good presentation.
Thanks.
Two questions. One, what does IMF stand for? And second is, when you do send it up, is there a future goal to do some sort of research, put something up there, and then have it up there for like a couple of seconds while it comes down, or something?
Okay. To answer the first question, IMF stands for International Martian Federation. Okay. That's because, like, one country cannot go to Mars. It's impossible. I mean, if we barely go to the moon, how we will attain Mars? Okay. So I believe it's by doing international cooperation collaboration that we'll attain Mars for sure. And to answer your second question, I have some projects how I could use payload. The first one is I want to make the sky rain because it's possible with rockets, and I'm really excited to going through that. After I really like the idea to go to asteroids and comets, and there's a lot of resources there that could also allow us to attain Mars. There's a lot of rare resources also on the moon that could be used in order to create technology also to go to Mars, I believe. And that's my goal in the future, I think. Any other question?
Then